In this video, we're going to build bicycles. You might be thinking to yourself, I thought this was a chemistry class. But you can learn a lot about chemistry through building bicycles. For the reason that when you look at their production, it's kind of like a chemical reaction. Now, assuming you have plenty of gears, chains, and brakes, and every other thing that goes into a bike that I know you're thinking, yeah, but that's not listed there. Just to simplify it, for every 2 wheels you combine with 1 frame and you can make 1 bike. So you have 2 reactants coming together to make a product. And they come together in a specific ratio, which is much like the chemical reactions we've learned about already. So now what we're going to start doing is looking at how much stuff we can make, because that's what this unit is about. Stoichiometry is like putting things together to figure out how much stuff you can make, or figuring out how much stuff you need to make a certain amount of product. So how many bikes could be made from 16 wheels and 10 frames? Well, all you'd have to do is say, well, I know I have 16 wheels, and I know that for every 1 bike I need 2 wheels. Therefore, I can make 8 bikes from that. With the frames, 1 bike requires 1 frame, so therefore you could make 10 bikes with the amount of frames you have. Obviously, you know that you're going to run out of wheels at this point. So whatever lets you make the least amount of product is considered your limiting reactant. It's going to limit how much product you can make, and then you're going to have left over of whatever the other reactant is, or the excess reactant. Now, this is kind of easy because you can hold a frame, you can hold a wheel. But say you were given a problem where you have 100 pounds of wheels and 100 pounds of frames in a box, and you want to figure out how many bikes you're going to make. So how many bikes could you make from 100 pounds of wheels and 100 pounds of frames? You'd need some more information, wouldn't you? What would you need? Good job. Yeah, you'd need to know how much each frame weighed and how much each wheel weighed. So, say all of a sudden this magic information came at you and said, well, each wheel weighs 2 pounds and each frame weighs 10 pounds. Then you could figure out how many of each you have and figure out how many bikes you could make. So, from the 100 pounds of wheels, you'd say, well, for every 1 wheel, it's 2 pounds of wheels, that's 50 of them. You know, and if 1 bike requires 2 wheels, then I can make 25 bikes from that. Going with the frames, if each frame weighs 10 pounds and you have 100 pounds of them, 1 frame, 10 pounds of frames, that's 10 frames. And from that, since it's a 1-to-1 ratio between bikes and frames, you could make 10 bikes from that. Now, chemistry, when we're looking at reactions, is a lot closer to this because we can't actually count atoms. And as we've learned this year, whenever you're trying to compare amounts of different elements or compounds, we always use moles. That's like our relative amount, like the number of pieces we have. You can't count. I mean, you have Avogadro's number of atoms in a mole of atoms. You can't do that. So what we rely on is what we can actually measure, and that's mass. So similar to like pounds, we use grams, to measure amounts of chemicals. So if you were given a problem like this is the Haber process here, where you're going to be making ammonia from nitrogen and hydrogen. And you can see from this that for every 1 nitrogen molecule, you'll combine with 3 hydrogen molecules and make 2 molecules of ammonia. This also can be represented as saying, for every 1 mole of nitrogen, you would react with 3 moles of hydrogen to make 2 moles of ammonia. Because a mole of any substance contains the same amount of particles, you can look at it as a molar ratio of the reactants to the amount of products you could make. So if you were given a problem where it asks you, how many grams of ammonia can be made from 56 grams of nitrogen and 18.14 grams of hydrogen, you should be able to figure out how much ammonia you could make. So going from grams to figure out how many pieces you have, or the relative amount, you have to divide by the molar mass of N2, which is 28. You get that from here. If N is 14 and N2 is 28, that would give you 2 moles of nitrogen. And knowing that this ratio says for every 1 mole of nitrogen you make 2 moles of ammonia, then that means from the nitrogen you'd make 4 moles of ammonia. If you wanted to figure out how much that weighed, you would just multiply the 4 moles of ammonia by the 17 grams of ammonia that would be present in 1 mole of NH3, and you would get a mass of 68.1 grams of ammonia you could make from the nitrogen. Now, looking at the hydrogen, you can see that, 18.14 grams, there's 2.02 grams in 1 mole of hydrogen, so that would be 9 moles of hydrogen. Looking at your reaction, you have to figure out how much ammonia you can make from that. So for every 3 moles of hydrogen, you can produce 2 moles of ammonia. So 9, 2 moles of ammonia, 3 moles of hydrogen, that cancels out. You know how many moles of ammonia you have. Now you don't have to do the last step of figuring out how many grams there would be because, looking at the amount of product you can make from each reactant, your nitrogen is going to limit you. So this would be your predicted or theoretical yield of ammonia you could make if you had these two reactants. So again, in chemistry, since we can't count the amount of particles we have, what we do is, and we can measure the amount of grams, we have to use moles to figure out the relative amounts that we have of one substance to another, and then look at the balanced chemical reaction to figure out what ratio they combine in and how much stuff we can make from each of the reactants based on what we have.